and welcome back to Chem Talk. On today's topic, we're going to be talking about the Heisenberg Uncertainty Principle. So this is a very important principle in the field of chemistry. So to begin this topic, we're going to be talking about Werner Heisenberg, the guy who actually formulated or created this principle. So to begin, Werner Heisenberg. Who was this guy? You may or may not have heard of him. So he was born from 1901 to 1976, so relatively recent. He formulated this theory. He's like the father, creator, whatever you want to call him, of the Heisenberg Uncertainty Principle. But his main role was being the main pioneer in the field of quantum mechanics. He actually had a very important role, and that's where he's most known, besides this principle, for the field of quantum mechanics. And all his work earned him a Nobel Prize. He was a Nobel Prize winner in 1932. So, again, very decorated scientist. So he formulated this principle through a series of thought experiments. So the experiment, again, called a thought experiment. So in this case, the thought experiment that he did to actually, create this was he tried to photograph an electron. And when he was actually trying to photograph that electron, the influence of photons or light particles caused this said electron to change its velocity. So that's one thing. It changed the electron's velocity, but it also identified the position. So he was accurately able to identify the electron's position, but the electron's velocity changed. So with that said, let's talk about this principle. So what does this principle exactly state? What does it even mean? So it basically says you can't know the exact position and velocity of the said electron at the same time. So you're not going to know exactly that because, the velocity will change, but you can identify the position. So the Heisenberg Uncertainty Principle is also known as just the Uncertainty Principle. You don't even need to be saying the Heisenberg, but to be more accurately correct, Heisenberg Uncertainty Principle. But again, what does this theory state? Again, the velocity changed, but the position stayed the same. So by trying to find or observe one of these values, like he was trying to find the position, you create uncertainty. Again, keyword here, uncertainty in the other one. Like he found the position of the electron, but he created uncertainty because that velocity kept on changing, so we couldn't accurately identify it. And this principle only applies to microscopic things like electrons. That's like one of the main things. Like if you throw a baseball around, you can probably most accurately find its position and location through a similar range. Like it might not be exact, but it's gonna be very close, unlike a electron, which is so small. So this principle has an equation, and this is also very important. So triangle x, triangle p is greater than or equal to h over 4 pi. So this whole left side of the equation represents the uncertainty of momentum. Uncertainty of momentum times the uncertainty of position. So momentum, velocity. So you multiply those together. So you were trying to find the product. For the left-hand side, it's the product of the momentum and position's uncertainty. So again, the momentum being represented by triangle P and the uncertainty of position being represented by triangle X. And that has to be greater than or equal to h over 4 pi, h being Planck's constant. So that means when you multiply the uncertainty, it has to be greater than or equal to Planck's constant over 4 pi. And this equation also states that when triangle X, or the uncertainty of position, is large, the uncertainty of momentum is small, and vice versa. So if one has a really high uncertainty, that means you're more certain about what the other one is. Kind of like saying you know one better and then you know the other one less because of that. So now, with all that said, let's do some practice to kind of recap. So pause this video, try to answer these on your own, and then we are going to be reviewing it. So pause the video. Okay, so define the Heisenberg Uncertainty Principle. You can't know the exact velocity and position at the same time. So the more you know about one, the less you know about the other. So the more certain you are about the position, the less certain you are about the velocity. You're more uncertain about that. So it's like kind of opposite and vice versa, obviously. So what is the equation? We just recap this. Again, triangle x, triangle p, greater than or equal to h over 4 pi. Uncertainty, the products of both those uncertainties, has to be greater than or equal to Planck's constant over 4 pi. And that's like a set equation. It's not going to change. So given the speed of an object, can I find its position within a close range? And by object, I mean like a baseball or football. Yes. Because, like I was saying, this principle only applies to microscopic things. So if you throw a baseball around, like I use this example over and over, you could most likely be able to find both of those. So that's it for the Heisenberg Uncertainty Principle. Comment below if you have any questions or reach out to us. We'd be more than happy to help. Follow the Chem Talk Education channel for more chemistry educational videos and help. And thank you so much. And again, please follow us and reach out to us for any questions. Thank you.